Hello everybody, my name's Mike Bradley and I'm a professor here in the engineering department at the University of Greenwich in Chatham in Kent. I run a research and consultancy centre here at the university known as the Wolfson Centre. Now you will never have heard of the Wolfson Centre, but I want you to know how important our work is to your daily lives. These are a number of the many products that our research and our expertise in engineering goes into. Our business is in powders, particulate materials. Particulate materials are the building blocks of everyday life. Almost all products that we have are made out of particles. This is grain, and grain of course is used to make flour. Flour is used to make biscuits, custard powder, many other things as well. And if you think about ore and coal and mineral materials and all of the basic building blocks that go into manufacturing, they're nearly all handled in particulate form. So just to take an example, one material we've done a great deal of work on, sugars. There are different types of sugars, icing sugar, caster sugar, granular sugar. One of the things about sugar, when you open a bag of sugar, you expect it to be nice and free-flowing, so you can pour it onto the spoon and into the tea. But if sugar is not handled properly, instead of looking like that, it gets to look like this. These are lumps of icing sugar, where it's been stored in such a way that there's been a temperature change, and that temperature change has caused these large lumps. So one of the things that we have designed is a process called a conditioning silo, where sugar is held and it's conditioned to remove a few parts per million of the moisture which cannot be got out by the normal drying process. And then after sugar is conditioned, it no longer forms these lumps in storage and transport. Now of course sugar goes into many of these other products here as well. If you think about the biscuits here, everybody loves a digestive. One of the things about sugar, if the sugar is too fine, so the particles are too small, what happens? The biscuit dough is a little bit too runny. And the biscuits, when you bake them, they expand to a larger diameter and they're thinner. And the problem is then, when you pack them, you can't get the pack round them. On the other hand, if the sugar is too coarse, if the particles are too large, then what happens? The biscuits finish up too small in diameter and too thick, so they then won't fit endwise in the pack. So part of the work that we've done on sugar, particularly for these biscuit manufacturers, is to design their handling systems so that they get sugar of just the right particle size so that the biscuits fit in the pack. Of course on here we have not only the sugar and the flour that goes into baking, and we've designed the systems for handling those at the biscuit factory, but also on the top we have chocolate. And chocolate also depends on particulates. It's made from beans initially. Cocoa beans are ground down, made into what they call chocolate crumb, which is mixed again with sugar and milk solids. But also with a lot of these chocolate products now, we have what they call bits in them. This is a chocolate bar with dime bits. Those little bits of dime bar are crushed up and they have to be kept distributed evenly within the chocolate bar. And if those bits don't flow in a regular way, then you'll get all of your bits at one end and no bits at the other end, inconsistent chocolate. So the design of the equipment that handles these bits is part of our portfolio. Crisps. What's your favourite flavour? Cheese and onion by any chance? Chicken and something else maybe? All crisps are born potato flavour. So how do they get to be flavoured? When I look at a crisp like this, if you look closely, you can see the seasoning on the surface, which is what gives it its flavour. It's little particles of the seasoning. So to make these crisps, from plain crisps into cheese and onion crisps, we have a mixture of cheese powder, onion powder, salt and other seasoning ingredients as well. And that seasoning ingredient has to be scattered on the surface. It needs to be sticky enough that it sticks to the crisp, but not so sticky that you can't separate the particles to scatter them on the surface in the coating machine. So the design of the seasonings so that they flow well enough but also will adhere to the surface of the crisp is also something that we've done a great deal of research in. So our research spans from the design and development of these powder ingredients through the manufacturing and handling of those powder ingredients and through the machines that use them as well. So another example of where powders is in our everyday life. Paint. What makes paint white? If you just made paint without any pigment in, it would be varnish, it would be clear. So the pigment, what makes the paint white, is tiny little particles of a material called titanium dioxide. And that material is very, very fine. It's about as fine as the particles in cigarette smoke. And of course, when you handle this in large quantities, it's very difficult to handle. So the design of the handling systems for the pigments in paint is something that we've done a great deal of work on all over the world, not only in the UK, but factories in China, India, and lots of other places also have incorporated our research into the design. Paper. What is paper made of? You might say wood fibre. Well, you'd only be partly right. The majority of the weight of paper is actually China clay. Again, small particles that make the paper white. Without China clay, paper would be grey. It would be a grey-brown colour. So again, we need the whiteness, we need the China clay. It also gives lots of other favourable properties to the paper as well. When the world's largest manufacturer of China clay came to us to say, we're changing our production from Cornwall in England to Brazil, what will happen? Will our customers, the paper mills, still be able to handle our clay? Because the clay was going to be refined and made into a solid, a powder in completely different machinery. And they had to have a big, virtually an overnight change. The last ship from Cornwall was followed into Europe by the first ship from Brazil. And all of the paper mills, if the clay from Brazil hadn't behaved in the same way as the clay from Cornwall, it would have stopped all the paper making facilities. So we did a lot of work to evaluate the flowability of the different products, to do some work with them on improving the way in which their products were made, so that when it came to that overnight change, it all went smoothly and nobody noticed that the China clay came from a different source. Got a headache by any chance? Or maybe a sore throat? Most drugs are delivered in what we call solid dose form. That is to say, either capsules, which are filled with powder, or tablets. And the tablets also are made out of powder, pressed out of powder. In these tablets, there are only a few micrograms of paracetamol. Now, you could not make a tablet you could physically hold with that few micrograms, so we have to have other ingredients. We have to have what we call excipients, which are the powders that make up the bulk of the tablet. Now, the excipients tend to be coarse powders, which are very good for making strong tablets. The active tends to be a fine powder, so it's bioavailable, so that your body can access it and process it. When we mix the fine and the coarse, what tends to naturally happen, just like the stones and sand on the beach, they naturally separate from one another. So the design of pharmaceutical formulations, so that when they've been mixed, they stay mixed through the handling and the tableting process, is an important part of our work. Not only the design of the formulations, but the design of the equipment as well. So we're not only talking food, pharmaceuticals, other household products. If you drive or ride in a motor vehicle, you rely on our technology in the parts in the engine. Lots of engine and gearbox parts these days, like these are magnets out of an ABS system. And these are made not by machining a lump of iron, but by taking iron powder and pressing it to make what's called a green compact, and then putting that in the oven so the particles stick together, a process called sintering. And this is the way that large numbers of components for the automotive and aerospace sectors are made now. So many other different products here as well. This is only a small selection of the many things that rely on our technology in terms of the manufacturing systems and the powders themselves. You may be interested to know the largest employing sector for engineers in the UK is the food industry. So not surprising you see there's probably a dominant percentage of food products here. So engineering has all sorts of faces. It's not just about motor cars or aeroplanes, it's about everything that affects our everyday life. And one of the nice things about engineering, a career in engineering, is that there's a place for everybody. I got into engineering because when I was really young, I was bought a Meccano set. And that really got me interested in making things and being hands-on. And if you're hands-on and you're practical and you like making models or these sort of things, there's a place for you in engineering. But equally, if you've got a passion for maths, there's lots of maths used in the work that we do. But you don't have to be an excellent mathematician. If your interest is in people and managing people, there's lots of that work involved in engineering as well. And there's lots of basic science as well. So in these products we work not only with our own specialism of solids handling, but of course people who are food engineers and food scientists and pharmacologists and agronomists as well. And again, this is one of the nice things about engineering, is that you can get to learn about so many different things, work with so many different types of people in all different areas.